Question 18. We've got some more sampling going on here. What is it? The mass of chocolates, blah, blah, blah. If we've basically taken a sample of 50 biscuits here and we're asked what's the chance that the total amount of chocolate is less than 365. So we'll let the examiner know our sampling distribution, normally distributed with a mean of 7.5, the population mean, and a standard deviation of variance 1.5 squared over 50. And then we've got to work out this probability. So I'm going to get my calculator up and head off into my e-activity. The file open, the regular specialist one would do nicely for this one. I'll use the normal CDF up here just because there's some calculations to do and we want to chuck out a few interim results. So let's start off with the standard deviation of the sampling distribution. It's 1.5 divided by the square root of 50. So when I press execute, there it is, 0.212. We want the probability of getting less than 365 grams in total. So that per biscuit would be the upper is going to be 365 divided by 50. And when we press execute, that's 7.3 exactly. And so now the lower would be negative infinity. So pop that one in. And the mean of the distribution was 7.5. And so kind of by doing it in here, we're calculating all the interim results to write down to keep the marker happy. Finally, we tap solve, and there it is, 0.1729 to the normal 4 decimal places for this type of question. So then when we scroll on down to part B, the probability that the mean amount of chocolate used per biscuit differs from the mean less than 0.2 grams is 98%. How many? Okay, so I think we're taking a sample here and we've got to work out the sample size so that the margin of error is less than 0.2 of a gram at the 98% level. So again, the calculator will kind of help us out here. I should have said there on the formula sheet is the formula for the sample size. So we want Z, S, and D. I think I normally use E, the margin of error here, which is 0.2. Right. We've got a copy of that in here. So if I shut this window, I want the Z score for a 98% first. So I'm going to tap into this window, put in my level of confidence as 0.98 and solve. So the Z score is 2.326. There she blows. And then when we go into the window above, there it is. It's already waiting for us. Now the standard deviation is 1.5. That's the population standard deviation. We want the margin of error to be 0.2. And you can see the formula here is the one right off the sheet. Tap solve, 304.4. So I'd normally write that down and then round it up because we want it to be 98%. It's, you know, who's going to care about the odd one? Anyway, so that's the next three. Over the page, and what's going on? A competitor company, a sample of 144 biscuits has been taken, and they found the standard deviation of the mass of chocolate in the biscuits was 1.8, and the total amount was this. And then Charlie Chocker said, we are using significantly more chocolate for each biscuit than Biscuits or us. If you want real chocolate taste, buy from us. What calculations are needed to comment on culture? Okay, so we basically got a single sample here from the other competitors, so we may as well assume, what about if this was a random sample from Biscuits or us? Is there any evidence to suggest that the sample mean is not 7.5 as we suspected? So our formula sheet gives us the confidence interval formula. Again, I'm going to just jump into my calculator here and go to the confidence interval for a mean calculator. I'm going to hit resize. Right, so the sample mean here was 1090 divided by 144, which we might need to come back to. That's N. The standard deviation of the sampling distribution here is 1.8 grams, and that was from so we're using the sample mean to estimate the population mean. The sample size was 144, and we want we may as well do 95% confidence interval. It's a fairly standard level, 1 in 20 chance that it's going to give us the wrong result. So we're in decimal mode. We hit execute, and at the end of the screen we've got our confidence interval. Along the way, though, we can give the examiner something to give us some marks for. So we did need the value of m. I'll just get that out on the bottom line here. So m is 7.569 grams, so we'll give them that, and then we'll give them the 7.569, this basically bottom line here, plus or minus the margin of error, which came from the z-score multiplied by the standard deviation of the sampling distribution, which was 1.8 divided by square root of 144, which comes out quite sweetly at 0.15 there. Anyhow, then at the end of it all, you can see there's not much evidence here to suggest that there is any difference here, and the confidence interval is 7.3 to 7.9 grams, which contains 7.5. So to finish off, we would say give them the confidence interval and say, as this interval contains 7.5 grams, the mean for the other company, there's no evidence at the 95% level that the amount of chocolate in these biscuits is any different to the Vicky's or us